Alright, so in this video, 15.1, we're going to talk about evaluating piecewise functions. So piecewise functions are a new unit that we just started. Basically, it's just a single function that has multiple different functions based on the domain. So it kind of depends on what part we're looking at, will depend on what the graph looks like. So if I look at examples, this is not going to be a long video. It's actually only this slide. Because there's a million different what-ifs we can do. But what I mean by piecewise is, so if you look, my function is this entire thing. So if the x values are between 0 and 5, my function is y equals 2x plus 1. However, if my x values are bigger than 5, I'm going to use the function y equals x squared. So it kind of depends on what part of the graph you're looking at will depend on what the function looks like. We'll do quite a few like real world problems where this exists. It's very common, and this is how you build. Most people have unlimited talk and text now, but if you don't have unlimited minutes on your phone, which you probably don't even know what that means, or unlimited text, this is more than likely how you're billed. So we'll see that more in class. But as far as this goes, so the first question it asked me right here is find f of 2. So f of 2 means what is the value of the function if the x value is 2. And really, instead of y, it should say f of x in the notation I have, but that's fine. So if I have an x value of 2, what is my f of x, or what is my y value? So first I have to determine which domain does 2 fall in. So my options is 2 between 0 and 5, or is 2 bigger than 5. So 2 is in fact between 0 and 5. So since 2 is between, since 2 is in this domain, I know my function is y equals 2x plus 1. So since 2 is between 0 and 5, I know my function's y equals 2x plus 1. So if x equals 2, what does y equal? 2 times 2 is 4, plus 1 is 5. So find f of 2. I have to determine that it is in fact in the first domain. And then now that I know it's in the first domain, I plug it into y equals 2x plus 1. And then once I plug it into y equals 2x plus 1, I get a y value of 5. The second question asks me to find f of 10. So I have to determine, is this x value of 10 between 0 and 5, or is this x value of 10 bigger than 5? 10 is in fact bigger than 5. So since 10 is greater than 5, I know my function is y equals x squared. If I want to know what y equals when x equals 10, I get 10 squared, so my y value is 100. Hopefully this is making sense. The last one is about as tricky as I can get. So this last one, I have f of 5. Now 5 is a part of both domains, sort of. The first says x is between 0 and 5. The second interval says x is greater than 5. So we have to determine which of these intervals is 5 actually included in. And I need to draw our attention to that right there. This second inequality symbol right here means that 5 is included. It means x is less than or equal to 5. So since 5 is included in the first domain and not included in the second, I know, so since 5 is in this domain because of this, so since 5 is in the first domain, I know the function I'm going to be using is 2x plus 1. And then, I'm going to plug in 5 for x, and I get a y value of 11. So when I ask you to evaluate piecewise functions, I'm simply asking to determine which domain the x value falls in. And then after you determine the domain that the x value falls in, plug in that x value into the corresponding function. This may seem silly. We're going to get some word problems and some application later. But for now, this is all we're going to do the first day.